Okay, we can go backwards too. So let's take the loading die. And the loading die will be 9x and 3x this time. So we also know that our reaction was 18 microliters, and we need to add it to run on a gel. So again, we have our reaction, and the reaction was 18 microliters. In this case, this whole reaction will be our solvent for loading die. And in this case, also what we know that the 1/k of this final volume will be occupied by our loading die, which means k minus 1 divided by k of the volume will be occupied by our solvent. Okay, so for this guy we could find a lot of stuff, so let's see. So what is actually really cool, that from the previous expression, which was 1/9 of final volume, is occupied by loading die, and 8/9 of final volume is occupied by our reaction. From this we could conclude that this is our, let's say, delta, and this will be 8 deltas, and 8 deltas are equal to 18. So what we do, we find delta equal 18 divided by 8, and that is so 2.2 and 5 microliters. So this will be your loading die volume. So good. So the next one was to find the same for the 3x loading die, and it will be the same. So 1/3 of the final volume will be for LD, and 2/3 of the same final volume will be for our reaction. And we can express it from here. So let's write it again. So 1/3 of final volume is LD, and 2/3 is our reaction. So this is delta, and this is 2 delta. And in this case, 2 delta will be equal to 18 microliters. Delta is 9 microliters. So we need to add 9 microliters of loading die to dilute it to 1x. And this is for your final volume. So we have 3 times 9 microliters, and it will be 27 microliters.